Good evening, everyone. Welcome to Advanced Course in Drones in Development. Today, we are going to be talking about something really amazing, and that is wildlife. So wildlife plays a very important role in the ecosystem of our planet. And fortunately, we have drones which are doing their bit of duty to take care of this sensitive species that we call wildlife. So here we have today Debbie Saunders from Wildlife Drones, who will be talking to us about her experience, her case studies, and her life as a droner as well as a wildlife expert. So Debbie, welcome to the course.
Great, thank you. It's so wonderful to be here. In a way, it's a kind of a funny thing to be introduced to sort of this drone expert because I wasn't when I began this journey. So if I can do it, anyone can do it. So yes, thank you. I've broken it up today into a couple of three different sections. The first section is a bit about my own journey and the journey of wildlife drones, the beginning of this doing things in a different way. Then we will go into sort of the more recent thing and examples of how this technology is being used, etc. And then in the wildlife space, but then also talking about some other sensors that can be used on drones for wildlife, and how we're also working to apply that in the agricultural sector as well. So a little bit of everything in this one tonight. All right, so I'm going to share my screen. Okay, just try and get it to go full screen. I don't think that's going full screen for some reason.
It is full screen. We can see the whole thing.
You can see it? Okay. All right. Right. Well, okay. Well, so this is the beginning of the story. It's kind of broken up into periods of time. So although we're here now and we're doing lots of stuff, but actually back at the beginning, it really was about these birds. There's kind of amazing migratory birds that I've been very fortunate to be involved with, and trying to understand more about them so that we can better protect them. So it's talking about how we've sort of gone as an ecologist, doing wildlife research, how I've gone from studying parrots to using drone payloads. But before we really get into it, I'd really love to get a bit more of a feel for who's on the call tonight, and find out if you're currently using a drone, and if you are, what do you use it for? And we'll see if we can actually put that in the, I don't know if we can do the chat thing, so that we can have answers to these questions. So feel free to just kind of enter this. If you don't have a drone, what would you love to be able to do with a drone if you did have one? Just so I can get a feel, and maybe the country where you're calling in from, because I think there must be an amazing collection of people here tonight. As I mentioned, I'd never flown a thing actually when I started on this journey, but what I had done was actually I studied swift parrots, and the swift parrots were, no, it's not actually changing. I can't quite tell what I'm actually presenting to you. I don't think you can still just see a drone, right? I can't see people and I can't see what's going on. Yeah. Oh, there we go. Sorry. I'll get there eventually. Yes, so I started studying these birds. We really didn't know much about them. They're migratory, which is quite unusual. There's only 3 migratory birds in the world, and this is one of them, and they're all here in Australia. And we really just wanted to understand more about their movements so that we could better protect them, because they were endangered. In the species breeds in Tasmania, which is down to in the south of Australia, and it migrates north for the winter. So in one year, it can be in one area, and another year it can be in a different area. It all changes each year depending on where their food is. And their journey can be up to 1,500 kilometres long from one end of their winter migration range to the other. So my job was to figure out where they went and what they did. And really I wanted to just figure that out so that we knew where to invest our resources and energy in order to better protect the species. So I did my PhD research on this species. I started off on a 6-month job over 20 years ago on this species, and it's just kind of kept building up over time. But we did find out a lot about where these birds were going and what they were doing. And we have a lot of drought cycles and then flooding cycles here in Australia, quite extreme weather events, and the birds have to respond to that on an annual basis. This is the type of habitat that these birds like to use, some old growth woodland. And what they're looking for are the flowers right at the tops of the trees. They're looking for nectar. They love carbohydrates, and they like to get quite drunk on this sort of food, and they will search vast, like thousands of kilometres, looking for the flower of these trees. So we figured out what the different types of trees were, etc., what they needed, but we'd never been able to actually track their movements. People had tried studying their movements, and they'd managed to catch them, which is no easy feat. They live at the tops of the trees, so actually catching a bird that lives at the tops of the trees can be quite challenging. But some people had caught some and tagged them and released them so they could track their movements, and never saw them again. And so it was like, okay, if we want to understand this, we actually need to come up with a better way of finding these tiny little tags that we put on the birds. We can't use satellite or GPS tags on these birds because they are too small. The birds are too small for those other tags. They can't weigh too much, or the bird won't be able to fly properly. So we're quite limited in what's possible to use on them. And so we were limited to VHF, or very high frequency radio tags. So I then sort of was talking to other colleagues who also were out trying to perhaps radio track other animals and people in different landscapes. And, people will go to extremes to pick up this little beep, beep of a radio tag and walk around with their arm up in the air for hours and hours. And I've done a lot of this over my career. And it really can be quite frustrating, but, quite crucial to understanding the movements of many animals, because most wildlife species in the world are actually too small for satellite and GPS tags. About 70% of the world's wildlife are too small. So while I was doing my PhD, I had a colleague who was also working on lions for his PhD in Africa, and we were just talking about, dreaming about what we could possibly do. And he had tried various tags and hadn't really got the spatial resolution of data that he needed. And this was quite a long time ago now. And I was lamenting about the same thing, but for these small birds. And he actually suggested, wouldn't it be great if you could use a drone? But this was well before we sort of really heard of DJI or any other of those major drone manufacturers. So I then had to try and find a way or find somebody who knew drones, and not many people did, but I did manage to find one group from the University of Sydney who were specialists in all sorts of field robotics. So I started working with them and got a whole bunch of partners on, and the Laurent Parquet Foundation provided some funding that we were able to then leverage other grant money. I had a whole bunch of partners from across Australia involved in the project just to see if it was possible to actually do this, because nobody had ever really done it before. So we had a number of years where we worked on this project, And we started off with the drone being used on a runway, essentially. So a very clear environment, very non-natural environment, but very uncluttered. So we were interested in developing the technology, and we did hundreds of flights, changed signal filters, different algorithms for processing, different antenna configurations. Over a number of years we were working on this and refining it. We then got to a point where we were ready to, we knew we could track the tags and everything. So like, okay, well, let's move into an environment that is more similar to what we would actually be working in when dealing with wildlife. So we moved to some adjacent woodland, which is here, and we would like throw tags up in trees and put them on logs and in different places to replicate being on an animal, and did some further testing. And while we were doing that, we were also doing some captive trials on the birds, on what is the best way to attach the tag, because they have a very sharp beak, but they also fatten up for migration. And so a harness, we tried harnesses, we tried different fabrics on the harness, we tried leg mounts and all sorts of different ways of attaching them. But after about 2 years of trials, we determined that we couldn't track a swift parrot. So that was quite disappointing, because we'd actually proven that we could track something with a drone, but we couldn't track a swift parrot at that point. So we chose another local bird that was territorial, so it would stay in this woodland. It's a noisy myna, which is there, and it's just a little tiny line coming off its back, and that's actually the antenna of the tag. So we put tags on these birds, and then we were able to demonstrate that we could actually track a wild animal with our drone in this sort of cluttered woodland environment. It was very interesting because being the first time, we didn't really know what to expect, and we this is a beam pattern, if you like, of whenever there's a signal that is propagated out. The one on the left here is the theoretical model of what that beam pattern should look like. The middle one is the noise that is around when you have a tag out there in the natural environment. And then when you've actually got it on an animal, it's incredibly noisy. So that's just a bit of an indicator that, like, just the theory and the reality can be very, very different. And that's probably one of the big challenges in getting this technology to actually function in the way that we wanted to, when you're having data that is actually quite noisy relative to what you're expecting to work with. However, we did manage to do this, and we then set about trying to demonstrate on a different species closer to home where I live, and showcase what we'd achieved right at the end of our project with all of our partners. So we set up this big project to showcase what was possible. We had people lined up to manually radio track, and the drone was going to track. We're going to have this big sort of showdown, if you like. But what we found was actually all the limitations of our system, and that there was a big problem in a number of different ways. That we could only track one tag at a time, which that in itself wasn't a problem at the time, because that was all that was possible with a handheld receiver anyway. But also the detection distance of the tags was really quite short. You had to be very specific frequencies. So each VHF radio tag has a specific frequency, and that enables you to identify individuals. But with this system, you could only have maybe 10 frequencies, and they had to be precise. And radio tags are not usually that precise. And so that poses its own challenges. People already have tags with other frequencies out there. But the biggest thing that really stopped us in our tracks was radio interference issues. Every time we launched the drone, there's signals from a nearby communications tower, which we didn't know were going to cause a problem at the time, completely stopped us in our tracks. We couldn't track a thing. I was quite devastated at the time. We put so much work in for years to get it to that point. And so I found that quite difficult. And we had reached out and asked a lot of people to come and help us figure out what was going on. And that's when we figured out what had actually happened. It was also you could only track frequencies that are used here in Australia, which obviously limited it. And then the flight time was really, really short. So this platform was very expensive, and its flight time was very short. So, but it was all that was available at the time. It was an Ascending Technologies Falcon 8 drone. So, yeah, that wasn't quite the story I was planning on telling, or the journey I was planning on taking, but we did learn a lot. And what happened then, once people found it, we were still the first in the world to achieve this. So there was a fair bit of media around it, what have you. And lots of people started contacting me and saying, how can I get one of these things? I'd love to have one of these. I'm like, I don't know, because I actually was just doing it for my own research and to try and shed light on this species, and I wasn't even able to do that. So I really wasn't sure, but I did look into trying to get some research grants and get that, do it that way so that I could get this technology out to other people as well. But I found it really hard because we demonstrated it was possible. Nobody wanted to fund any more research on it. So, but we'd identified all these things that needed to happen for it to be useful. So I then just set about educating myself on how I might translate this prototype that we'd developed into something that was actually a practical tool for people. I had no idea how to do that. So I did a course, probably much like what you're doing now, and just learning and embracing, understanding different things, lots of innovation courses on this idea of creating something of value for the world. So that's how I began the journey of wildlife drones. And up until then, it really wasn't, I didn't do any of the flying in the initial project. We had a pilot who did all the flying for us. I was the one who had to run around with my hand up in the air, tracking the birds to validate the data from the drone. So I could see the benefits when I was running around. And like, one day I'm going to be flying the drone and not the person with the antenna up in the air in my hand. So I guess that's the first kind of phase of the journey in learning a lot. Being an ecologist who goes around and had been studying birds for quite a number of years, to all of a sudden working with technology and roboticists and RF engineers and a whole bunch of people with different skills. And something that I really loved, because I did love collaborative projects and working with people with different sets of skills. So I certainly enjoyed doing that. So that's kind of the intro section. I'm just going to flick back to that first slide that I had up about the questions for you. And hopefully you can still see. Yeah, so I might have a look see if I can actually see the comments and things in here. I don't know that people are putting things in there. So if anyone would like to put in some of their responses about whether you currently use a drone, if so, what do you use it for? And if not, what would you like to be able to do? I'll give people a couple of minutes to have a go at that. I just stopped presenting that one, or actually maybe I should copy those into. Oh, you've already written it there, Ruchi. Thank you.
Can we have some hand raises, please?
Okay. Pull up my next presentation. I hope I haven't put you all to sleep.
Yes, Nikita. We have a hand raised
So
from Nikita.
I
Nikita,
was
you can
just
introduce
typing in.
yourself. No problem. You can introduce yourself. Where are you from, and what do you do, and your aspirations with drones.
Sure, sure. Hello, Devi. First of all, thank you for coming here and providing us the session today. So my name is Nikita Shrestha, and I'm from Nepal. Currently, I'm working as a software engineer in Livestock. So basically, my major portion of work is building a data-driven solutions. And till date, I haven't got chance to directly use drones technologies, but I was always fascinated by the applications that we could do using drones. So one of the things that I would like to do is monitoring the aquatic animals like seas. I just I wanted to do that because I love seas. I love traveling, and also in at the same time we could monitor the species around, what their status is, specifically to be specific, by using drone maybe I would like to watch around the blue whales, the biggest planet animal on the earth, I guess. That's it.
Awesome. Yeah, look, there's some great work going on monitoring aquatic animals. Here in Australia, there's a number of groups who actually have capacity to use some AI and able to identify species from imagery, and in particular for sharks. There's a fair few shark attacks happening, so people like to know where are the sharks, and just so that people can be alerted if a shark is nearby and things like that. But also monitoring dugongs and maybe sea turtles and other marine life as well. So I think there's a lot of work in that space. So I think it is an exciting space. And I think over in New Zealand they've got these big fixed wing drones that they use to monitor the really rare Maui dolphins as well. So there's certainly a lot of inspiring projects around doing just that.
Thank you.
Okay. So is there anyone else who would like to contribute to that conversation?
We had a veterinary doctor here, but I don't think she's here today. So
Okay.
this group has one, and she really was interested in using it for animals. So I wish she would have attended the session today.
Okay, no worries. So I'll move on to the next section, which is more about sort of where we're at now and what sorts of things we're getting up to. Okay. Right. Funny, I can't really see. Oh, there we go. Okay. I'm just going to move it so I can actually see it better. Sorry. Okay. So, is that full screen for you? Oh, there we go. I got it now.
It is.
Yeah. Okay. So this is where we're up to. This is what our system looks like right now, and I think one of the biggest things in developing some new technology was really to get a really great team of people together. And is it similar along the lines of the original project when we had a whole bunch of different people with engineering skills, etc. working together. So for me, this is one of the biggest and most important things, is just to surround yourself with pretty amazing people. And these are the people that I've been very fortunate to surround myself with. This is our current team, and yeah, it's just quite diverse, and we have people working on marketing and communications, right through to software engineers, technical support for customers, industrial designers, RF engineers, drone pilots, etc. So there's a really nice suite of skills, and everyone's really passionate and creative, and just absolute delight to work with, really. So I feel very fortunate to have this team together now, and to have some investors who have given us this opportunity to find this team and grow it to where we are now. Some of the things that we've been able to do since that initial system, we've completely rebuilt our system. So we can, instead of tracking one animal at a time, we can currently track 40 simultaneously. This is quite a game changer for a lot of people, because with the handheld system, you can track one at a time, and you have to actually rotate between them. You can have it scanning if you like, but every time you're listening for one, you're not listening for another. So there's a lot of scope of missing animals. We have much greater detection capability. We can detect tags from further away than we ever could before. And we also have some really stable real-time communication as well. So on the drone here, you can see that it's actually just a DJI Matrice 210. So this platform is a really nice size and can carry multiple payloads. And there's a gimbal on the front here, which we don't use most of the time. So unlike most drone applications, ours is a listening drone. So across the legs here, you can see an antenna. This is a VHF antenna beam with some elements that stick out here. This is to pick up the radio waves, and that's what does the actual listening. And then it's connected to an onboard computer at the top, which does some signal processing and some initial, it groups the data into little packets so that it can be communicated back to the base station. We originally had very flaky communications, but we now have pretty rock-solid communications on the drone, which enables that real-time data feed. So it's immensely helpful, because you can, while the drone is in the air, you can see on the screen exactly what the drone is hearing. So that's really quite valuable for guiding the pilot on where and how they should be flying. There's also been some developments recently, just this year, where we actually can use the drone in different modes. So once you have the tagged animals out in the environment, and this photo is actually from New Zealand, just before COVID hit, we were out on an island off the coast of New Zealand tracking kakapo, and it was a great opportunity for us, because it's a place where there were 99 birds tagged on this island, and so you can imagine if you're tracking them one at a time, that's quite a massive task, and you can see the ruggedness of the landscape there. Can be very tricky to move around. So we could just go down to the beach and fly the drone, or we could go up to the top of the island and fly off some rocks up there, and we could cover really large chunks of the island in a single flight, really. So that was really a great experience. But now we can actually search for tags, which means you can actually just fly as far as you can within the limits of what you're allowed to do. And we actually can drop breadcrumbs on a map. And if a signal is detected, it just lights up. And so you know immediately that you're detecting a tag, and you can click on it, see the information, etc. And then the other mode is actually if you're trying to actually triangulate and get a coordinate on a map of where that animal is. And I'll show you a little bit more about what that actually looks like on the user interface in a moment. The other things that we've incorporated are some pretty serious radio interference algorithms and filters and things like that to deal with the noise that is in our world. It's an incredibly noisy world that we live in even in some of the most remote places we've ever been, is still quite loud in terms of radio signals. There's often long-range communications, etc. That happen. So it's a really critical thing for the effectiveness of a system like this to have that, dealing with that radio interference. We also now can track any VHF radio tag from any country in the world, so it's international. Any 2 megahertz band, the tags can be detected within. So it really can be quite flexible. It doesn't really matter what the different countries' regulations are. It can be used. And we found it really interesting when we were working with some clients who had GPS data loggers. So that's a tag that actually logs the data on the tag, and in order to get the location data back, you actually have to get close to it. It's a close proximity data download. And so we worked out that we could actually attach a GPS download system with our antenna and also download that data from further away than when people can do it from on the ground. So that was really nice, because it means that there's a broader range of, applications of this technology over a different range of sized animals. So slightly bigger animals can have these types of tags. Another recent feature, which is really critical for a lot of projects that our system is used for, the release programs. So a lot of animals, usually threatened species, are endangered, and so there's captive breeding programs. And those animals are then released back into the wild, and they've invested heavily in these animals, and so they really want to understand, do they survive? Do they contribute to the conservation of that species? And so understanding the mortality or otherwise, if they're alive or dead, can sometimes be the only information they really want to know on a regular basis. So we now have the ability to not only listen to those signals going beep, beep, but we can actually determine what the pulse rate is. And if we can read what the pulse rate is, we can say whether it's dead or alive immediately as soon as the drone is picking up that signal, and you can actually see it on the user interface. So this is a whole new level of capability, in addition to being able to track many animals simultaneously. So we by far have the world's most advanced drone radio tracking system. This is what it looks like up close. The receiver system on the top actually just screws straight into the top mount gimbal. 4 screws on the top, 2 cable ties around the legs, and it's attached. So it's independent of the drone. It has its own battery, its own power source. It has its own sensors, so it's GPS, IMU, etc. So there's really no integration. It's just clip on, and you can go and fly. So it makes it very simple, very easy. Unlike our first system, which was robotic, so it sounds pretty cool, but it actually limits what drone platforms you can work with, especially, and if that's a really, really expensive one, then it's not very practical for a lot of people. So how it works is that we actually have to tag the animal first, because we are listening for signals from that tag. Attach the system to the payload. Attach the payload to the drone, and then go fly. And while it's in the air, the data is fed back onto a base station laptop, and it's processed in real time. So, and no internet connectivity is required. Most of our customers don't have any sort of internet, even if they're just outside of a big city here in Australia. The internet's very, very poor. So, so it's really important that we don't rely on having connectivity in order for this to function. So even in really remote areas, it can still be used because it has its own communication network. The only thing that you do need connectivity for is if you want to actually download maps onto the base station to use, you can do that before you go out. But if you already have some maps, you can actually put them on there as well if you like. This is an example of what the user interface looks like. We've tried to, because I guess I'm an ecologist, I'm not an engineer or a technologically based person generally. I think that's been helpful in that there's like, I don't want an engineering user interface. I want something that I can understand as an ecologist. I want to see points on a map where the animal is, and I want to be able to click on that point and see exactly what animal it is, what the coordinates are, so I can go and find it on the ground. I might want to observe its behaviour. I might need to retrap it to replace its tag, those sorts of things. So there's that's the sort of things that I wanted to display. So the biggest part of it is just the map. And how it works is we go from top to bottom on the left-hand side through the buttons. We set up some folders, so all the data is collected into a folder and organised for you. You calibrate the system, and then you just send the tag information, so whatever frequencies you have on your animals, and you push start tracking. And so then you launch the drone and start moving it around the site, and you'll very quickly start to see any tags that are within range. And across the bottom of the chart here, you can see there's some peaks happening. So wherever there is a solid line, that is actually a tag frequency that we're looking for. And where you see the peak on that chart, that's actually a positive detection of a signal. If there were no signals, it would be flat. And so you get this information coming through, and that graph is changing all the time as you're moving around. And what you really want to see is when you're pointing in one direction, it's really strong. And when you're pointing in the opposite direction, it's actually really low. So you actually want both the strong and the weak signals, which then allows you to get a direction. You actually can slowly rotate the drone. And from that first rotation, you will actually start to get bearings on the map. So you get some arrows popping up to start with. And then in order to get the points on a map, you move the drone to a perpendicular location where you're trying to get intersecting bearing lines. And as soon as you get two or more intersecting lines, you start to get these points on the map. And there's also an error, a confidence, I guess, interval around that point to show you how confident we are that it is at that coordinate. So that's how it all works. And it really, the drones themselves are very simple to fly. They are a professional grade drone that we're using, and we're using one of this size. It's a 6.2 maximum takeoff weight drone, 6.2 kilos. And so it's big enough to carry a payload that is reasonable. So our payload weighs about a kilo, just under a kilo. And so it has to be big enough to support the antenna and also carry the weight in order to do this type of work. To give you a bit of a feeling of the different types of projects that we've been involved in or contacted about that we're still talking with people. We've done everything from trials for tracking turtle hatchlings. This is something that's still in development over in Western Australia, where no one has really been able to effectively track turtle hatchlings once they go off the beach and back into the ocean, and really study how they maneuver. And then they're trying to look at the impacts of artificial light and things like that on the movements of the turtle hatchlings. We are also exploring the livestock market. We now have some tags that we're doing testing on farms and looking at both sheep and cattle, but could be applied to any other animal really. We've tracked goannas, so this is a giant lizard that we have here in Australia, and well as some small birds. And we've had inquiries from South Africa. And we're hoping to be able to get our technology over to South Africa very shortly. And then some inquiries also from Chile, and we've tracked some tags from Brazil, giant armadillo. We've done some testing with that. But we also have a couple of projects now in the US as well. One of them is an interesting one for us, because they're tracking microbats on migration, which must be one of the most challenging things in the world to study the movements of. And they're using piloted aircraft to track them. But we're using our system on the aircraft. They can now track up to 40 animals. You can imagine if you're flying in a human piloted aircraft, you're traveling big distances very quickly. So the potential for missing the very animals that you're trying to study is huge. But you can see there's other parts of the world that are also, like, we have been in touch with people from all over the world largely, and really fascinating to always hear about the different applications. Some of them are problems in managing invasive species or animals that have become pests, right through to really endangered species that need protection. These areas in the circle, this is all the projects that we've delivered so far, and I'll go through a few examples of those. So one of the really lovely things for me was that swift parrots, we weren't able to track them as part of our original project, but we persisted in trying again and again with different attachment methods. And we finally actually discovered that we could attach some tags, and you can see again the antenna of the tag is pointing down here. But what we couldn't put on a long-term attachment, so we're unable at the moment to be able to study their migratory movements. However, we can study them within the wintering or the breeding area. So we can attach these tags just with some specialized tape onto the feathers on the back of the bird, and they actually do chew the tag off over time. They just chew through the tape and it falls off, which is great for us because we actually know that bird is then not endangering itself by having a harness or any other materials on them, because they do clamber around in amongst the leaves and are very subject to getting entangled. And they nest in hollows. So if they imagine that they're squeezing into a rugged, like a jagged hollow entrance, they could easily get caught. So by doing this attachment method, we can be certain that they're not going to get entangled, and in fact they can just get rid of it if they really don't want it there. So we just have a shorter period of time, but it was great to be able to track them, and we were able to find a roost site. So we only had a small number of birds tagged, but one of the great things about tracking tagged animals is that it can shed light on all the other animals that they associate with as well. And it's a very social species. And so from just tagging a handful of birds, we actually found mass roosting sites with a really large portion of the population, where they were going every single day and coming together. There were hundreds of birds. It was quite a phenomenal sight to see every day. And we were able to get a really good count and a much better understanding of what the birds were doing. And these sites were on private property. And so we were able to talk to the landholders, etc. And we were able to give some money to landholders to actually protect and restore the habitats for this animal. Unfortunately, the site that we have here is being bulldozed at the moment. And so we also have the negative side that we know this is an important site, but the vegetation laws in Australia sometimes are somewhat lacking. And even though it's an important site, their habitat is being cleared, even though this species is critically endangered and quite close to extinction now. So we still have our same issues. So I think it's really important that this data really enabled us to highlight just how concentrated these birds can be and how important even quite a small patch of habitat can be for the long-term survival of the species. We then also were asked to come and help and find some koalas that were being radio tracked after the horrific fires that we experienced not that long ago. And so you can see on the left there, some of the forests are just obliterated and there's just ash. They're white on the ground. It's just ash. There's literally killed some sections of forest. our forests are adapted for fire and you know, often will recover, but the intensity and extent of the fires was completely unprecedented. So there were some researchers looking in both burnt and unburnt areas, and some of their koalas went missing, and they really needed to find them for ethical purposes to check that they were going okay after they were tagged. So in this example, we went out in one day. We were able to actually survey 16,900 hectares because these animals can have tags that can be detected from 7 kilometres away. And so in this, it doesn't look too hilly in that picture there, but over the back of that mountain range, it actually drops off and gets quite steep. And there's a lot of gullies and convoluted landscape features, which means that if you're radio tracking them from the ground, the signal gets blocked. And so you spend a lot of time walking kilometres and kilometres up and down hills looking for one animal at a time. But with the drone, we were able to put in those signals for all of the tags and actually track them all simultaneously and search areas that actually hadn't been searched before because it was just too inaccessible. This is the beautiful goannas that we have in a nearby national park here, and this is one of the first ones that we went out to, first species that we went out to track, and they're very specialised goannas, and they nest in termite mounds on the ground, and they really wanted to better understand the movements of these animals and understand the features in the habitat that need to be protected for them to survive. So they had both GPS and radio tags attached, but we'd been out tracking these animals and I hadn't actually seen one. And so I really wanted to see one for myself. So I asked the researchers because we can track from a distance. That's one really great thing about our system is you don't have to disturb the animals at all. We don't have to go close because we're not looking, we're listening, and we can pick up signals from quite a distance away. So we went to go and have a look at the goannas, and as soon as we got close to, they're very, very shy. So they really don't like to be seen. So they dived down a big burrow that a wombat had created. I didn't even get to see them. But when it was underground, I was like, it'd be really interesting to know if we can actually pick up the signal from this animal that is underground or not. So they actually stayed there and watched the burrow to make sure it didn't come out. And I ran back and I launched the drone about half a kilometre away or so, and just to see if I could pick up the signal, and I could. So that was pretty exciting for us because we knew that we could then even track animals when they were underground if they had a decent enough tag size. But these goannas also had GPS logging, which I spoke about before. So we were able to put the GPS system on the drone and collect some data that way as well. So we learned a lot on that trip, which was fabulous. This is when we were down in New Zealand, Trackingkakapo, and this is the other side of the island where we walked up to the top. There's not many walking tracks, but there's just one, and we carried the drone up with a backpack full of batteries and a bit of a raincoat in case it started to rain, because it is New Zealand, it rains a lot, but we were very fortunate with the weather. And from this one location, we could cover almost, a third to half of the island. And in 2 hours of drone tracking, we did the equivalent of more than 4 days of manual tracking for 2 people. So there could be some really major savings in terms of the time and the effort, which means that it's not to say that people, can't, we don't need people to go and do this work, but what it means is that the people can do more meaningful work. So once you've got the location, they can go and do the observations or measure the habitat or get other information, health information on the animals. So it just means that you can actually increase your capacity to understand the animals rather than spending all of your time simply trying to locate where they are. It's a very, very different landscape. So this is a really flat, swampy coastal salt marsh. And these little parrots here are called orange-bellied parrots. And this is one of the other migratory parrots that we have in the world. These tiny little birds is very, oh gosh, I'm not sure what the total population is at the moment, but maybe like 120 birds in the world. So there's a lot of captive breeding going on and releasing, and this is one of the sites. So they want to study the survival of the birds released, but they hop around on the ground in this salty environment, and the signal detection range is really short for these birds. So the great thing with the drone in this instance was that because it's so flat, when people are tracking by hand, there's no high point to maximize that signal strength. And so very, very short detection distance. But from the drone, just going up, you don't have to go that high, you go 40 meters or so up. You could fly a really long way, all the way along that coastline, and cover the entire habitat strip, because it's actually quite a narrow strip of just a couple of 100 meters wide along the coast. So you could really cover major areas of habitat very, very quickly. So that's a really nice one, and interesting for me, because I guess I'd always thought that if it's flat, then it'd be pretty easy to pick up a signal, but it actually isn't the case. And we've demonstrated that in other landscapes as well. And one that is also, again, we actually didn't know if it was going to work, our system, in this tropical forest environment. So we were talking to Save Vietnam's Wildlife, and they have this amazing program, and I think they've just won some awards, prestigious conservation awards for Ty, who heads up that organisation. They do really fantastic work, anti-poaching work, rehabilitation and release of animals, but they find it incredibly difficult to be able to track anything in this landscape. And you can kind of see where there's a road cutting there. There is one road, and that is it, in this vast, vast area. And it's very steep, and it's very wet, and it's very dense. I don't even know how they think about tracking in that sort of habitat by hand. It's so difficult. They could have a team of people looking for one animal for several days and maybe not even find it. That's how hard it is for them. But they really wanted to demonstrate that they're having a positive difference for this species. So we went over there and just said, well, look, we don't know if it's going to work, because this forest is very dense and wet, and that two things that typically is not a great thing for radio signal transmission. But we went out there and we put some tags out in the forest, not on the animals, but just trialed it to start with, got some locations of them and looked at the data and went, actually, it's working. That's pretty cool. So we did some more trials. We trained up their staff just over a few days, and then we went and actually got some animals that were ready for release. They got tagged, and then we took them straight out there and we released them into the wild, and then we started tracking them. And for the first time, we were actually able to track multiple animals simultaneously, and of course they all went. So, one went over this ridge, one went the other way. And so immediately you had to start searching further and further afield. And it's really convoluted landscape, topography-wise. And so, having the drone and being able to go over ridges and point the antenna into gullies was a real game changer. So that was a really exciting development, to know that we knew we could track in grassy open woodland and tall forest. It was quite dry here in Australia, but we hadn't tried in this tropical landscape, and now we know that actually it's very effective in this landscape as well. You have to have a tag that's big enough or powerful enough to transmit through the canopy. But for a lot of species that inhabit these places, VHF transmitters are the only way that you can actually track them, because GPS and satellite really struggle to work underneath a dense canopy. They just don't get enough satellites to get high quality data. And they can sometimes, they run out of battery because they really are working so hard to try and get a fix that the whole thing kind of fails. So the fact that we could do this was quite exciting for us and for them, and they've been using that technology ever since. So their team, then just went out and did the flying when they needed, and they've helped us immensely in our advancing our technology over time as well. So that gives you a bit of a taste of the sorts of projects that we've been working on, and we'd love to actually go and work in many more places and many more landscapes, and really push our technology to the limits and see what might be possible, and try and, I guess, contribute to many different programs. And I have actually done, for my own research on swift parrots, I've worked on this one species for 20 odd years, and yet now I feel like by developing this technology and making it much more user-friendly and being able to train people quite quickly in how to use it, I can really try and contribute to many different projects all around the world. So it's very satisfying for me personally, to know that it's possible to do that. So that's my journey, kind of up to this point, I guess, is where we're up to at the moment. So are there any questions that people have?
So this was an amazing presentation, Debbie, and thank you so much for sharing it with us. So we have 2 hand raises from Sushmita and Nikita. So Sushmita?
Yeah, hello ma'am. Hi Debbie ma'am.
Hi.
Hi, and my question is, I know there's a very much diversity in wildlife, so there are camouflaging animals also. So how does this drone technology? What kind of drone technology is used to detect or track camouflaging animals? I'm pretty much interested in camouflage because my project is also on detecting and tracking objects that are camouflaging or hiding or concealed in such different environment, and that are not easily able to be visible with on data through drones or airborne or satellite data. So how can we track?
So I'll just clarify the question. So it's about how you can survey animals that are very camouflaged and might be very difficult to actually see, to monitor. Is that the?
Yes.
Yeah. Cool. Well, this is the nice thing with this system, that because you're not using visual data, you do have to catch the animal. That's the trick, I suppose, in this instance. And there's certainly in Australia, there's lots of you have to apply for an ethics application, that how you're going to do it so that it's in a way that doesn't endanger the animal. But you have to get the right tag for the right type of animal, and then once they have that tag, you might never see them, but you can track them. You can still find where they are. You can get the coordinates of where they are, and you can go and find what it is that they're using if they're really difficult to observe. So with this system, it is quite key that you're able to catch the animal and tag them. But I think for other animals that are quite cryptic or camouflaged with their environment, thermal cameras can also be used, depending on the density of the vegetation and the size of the animal. Obviously, the bigger the animal and the more open it is, the easier it is to use thermal imagery for finding animals. We use this, for example, a lot for koalas. Although they look quite big and they sit at the tops of trees, you think that they will be quite easy to find, but they're not. They're very, very difficult to find. And they're sleeping most of the time, so they're just kind of curled up in a ball when we're trying to find them. And so we do, there's a number of different ways that you can try and locate them. You can use detection dogs. You can look for scats or little their poo on the ground to get an indication of whether they might be there. But you really don't get a density estimate or understand the population in that way. But with the thermal cameras, you can very quickly get a very good idea of what animals are in an environment. And most of the wildlife here in Australia is nocturnal. And so you won't see them, the mammals at least, they won't see them out during the day. So they're out at night, they're cryptic, they're hard to find. But with a thermal camera, they just pop out. If you just have to get the right altitude and the right camera gear, and you can find all sorts of different species much more efficiently. And in that case, you don't have to tag them. You're actually just looking for animals that are in the environment. And for koalas, as an example, you can actually use the thermal imagery to start with to find where the animals are, and then you send people in on the ground to that point where the drone got a coordinate, and they can actually then catch the animal to tag it. So you can actually quite complementary technologies. And so we started out just doing radio tracking because that was what our need was originally. But we have been approached more and more to do thermal imagery as well for that very reason, that are really cryptic animals. So that's been a really valuable tool for us. And we've got it's mainly koalas, but also invasive species. So actually being able to control animals that are pests, it can be used in that context as well.
Yeah, thank you, Mom.
My pleasure. So I can see another question there. Thank you. How have you managed to cope up with the operation under thick foliage or canopy cover? So is that managing the actual drone flights when you have or picking up the signals?
Amit, would you like to clarify?
Actually, we know that radio signals and other signals tend to bounce off from many surfaces. So canopy cover and stuff sometimes reduce the effectiveness of your tracking tools. Other than that, let's say you are successfully able to trace down an animal, but again, if you try to track down the animal using a drone, but it comes under a heavy foliage cover, how do you manage that?
I think the tag just has to be big enough to transmit. So if you're tracking something really tiny, the signal, it just may not penetrate the canopy. But for the pangolins, for example, because that is the ones that we have been tracking the most under dense canopy, the tag for that animal is about the size, less than the size of your index finger. So it's not tiny, but it's not huge either. Plenty powerful enough to be able to pick it up. So for the pangolins, we can pick up those signals from about approximately 2.5 kilometers away. So you can imagine that if something is that far away and you can pick it up, then it's no different to tracking in more open habitat, really. But it does have to be powerful enough to make it through the canopy. So it'd be good to, I guess, get a feel for that. If you can get any high point where you can track animals. We have put out tiny little bird tags into some dense forest here up in northern Australia just for a demonstration we did in one occasion, and there was definitely a very weak signal because the tag was really tiny and it was down low near the ground. So all of those things do impact on the signal. But if you have a good radio tag that's got quite a strong signal, then it does actually penetrate the canopy and you can just track it as you would for other things. It sounds like you've actually done some tracking, Amit.
No, I haven't
No?
done, but
Okay.
yeah, haven't done, but yeah, I was planning to not rather planned, rather had a few thoughts about giving a try, but then this pandemic and stuff came up.
Yeah, cool. Yeah, and I think you do the communication links do tend to be shorter in a dense forest. So I talked about the real time communication, but when the drone is in the air, because it's a nice line of sight to the base station, that link is fine. But if you are flying quite low and you get dense vegetation, you might find that the communication might come in and out. For our system, it doesn't really matter. It just keeps collecting the data on the drone, and when it comes back into connection, it just catches up, if you like. So yeah, it hasn't proven a problem yet, but I'm always keen to see where we can push the boundaries and see what the limits of that are. But we haven't had it stop us from tracking anything yet.
We have a question from Nikita Shrestha. Nikita, would you like to go ahead?
Yes, first of all, thank you for the presentation. So, I just had a query regarding the backstory of, like you mentioned that you were able to detect only one animal at a time during your prototyping phase. So, how did
Yes.
you move to, detecting 40 animals, I guess, right? So now you're able to detect 40 at a time. So what changed throughout that phase?
The whole system. uh, we just went, okay, that one doesn't work. We need something completely different. So we had a different SDR. We also had we developed completely different software behind it, and different signal processing algorithms. And we actually we're about we're building up capacity again because we have actually fine tuned the collection of the data in very small packets, which enable that longer range real-time communication. We soon will be able to actually do 100 animals simultaneously as well. So it really is about the quality of the SDR is software defined radio. So we have an SDR that we use, and we've got a lot of electronics that we've built in the antenna as well. And so we say 40 animals because how we do it is that when we input a tag frequency, we can we have the line, we put a solid line at the actual frequency, but what we're actually listening for is a 10 kilohertz band either side of that tag. So that's why it comes down to 40, because you have to allow for a little window around each tag, because radio tags do tend to drift a little bit in terms of frequency, and you want to be guaranteed of capturing that signal. But as I say, we've built, the capacity is increasing all the time, and we're actually hoping to be able to track coded tags as well. It's a work in progress at the moment. But what that means is you can have one frequency and you can have hundreds of animals on one frequency, but with an electronic code embedded in it, that you can then decode once you've got the signal. So we're quite interested in exploring that, because then you actually can you can scale up your operations, if you like, and collect more data from more animals. But there's always the technical limitations of actually the bandwidth and how many animals can be in close proximity at the same time. So there's always technical challenges whenever you're changing the scale of what you're doing. But it's actually, it's been really great to sort of find that sweet point at the moment where we can confidently have 40 with no blockages in the communication. We could do more. We have done more in the past, in fact, but it actually would get a bit clogged up. So we found that this is something that right now keeps everything highly functional if we stick to 40. But because we've improved lots of other aspects of the code behind the scenes, then we actually are aiming to be able to increase it even further soon.
Okay. So thank you. I had another question as well. Like, so when we are tracking animals through drones, I'm not sure, but we generally tend to track its location, like where it is now, or how it's pulse rate is going at, as you mentioned, like is it alive or not, to detect something like that. So through that, only through that data, are we able to track their behavior, or there are some extra information that we merge to do the analysis?
Yes, so that comes down to, well, it's actually about not just the analysis of the data, but how it is collected. So we now collect data in a very different way to the way we were before. I'm not actually the technical person, so I'm probably not the best to explain it to you, but it's basically we slither it up into tiny little pieces and collect it more frequently. And so and then we actually can take a deep dive into the data that is collected, and we can have reporting on the sensors to make sure the sensors are working correctly. So we have had lots of challenges, because every piece of hardware that you incorporate or try and advance the system has pros and cons, and until you're actually able to collect data on your sensors as well as the data from the animals, it's very difficult to differentiate what is a software problem, what is a hardware problem, how do you actually work your way through that. And so we're at a point now where we have a much greater understanding of what is impacted by what factors, and actually able to manage that. And as part of that process, we are able to now detect those pulses. So if the dead and alive is the main thing that you're interested in, you don't have to rotate the drone. You don't have to, you could just fly it around the site, and you actually, while the drone is in the air, what is actually happening in the background is that all of the signal information is being recorded every few seconds and appended to a CSV file. So when you finish, while the drone is in the air, the CSV file is being used to do the mapping and show the signals and all that information in real time. And when you finish your tracking, you have everything in a CSV file that you can use. You can put into your mapping software, etc. And we report both with the signal down the bottom. We have a little number just above the signal which shows you the pulse rate. So as soon as it's detecting a signal, you can see exactly what the pulse rate is. So for the mortality signal, it tends to be the pulse rate either is made quicker or slower. So it might be 40 to 60 pulses per minute for your average tag or a live animal, and it might be 80 pulses per minute, for example, for a mortality signal. So as soon as you see a tag that has 80 pulses per minute, you know that something is wrong with that animal, and you can get someone to go there. You can actually locate it if you want to go find them. But if all you want to know is it dead or alive, you can just fly it around, and that data will be collected, and it'll be there in real time on the map and the plot, but also in a CSV file. So you have a data output that's useful immediately. But you do have to have a USB stick and back it up when you're in the field. Sometimes people forget to back up their data, and that's never a good thing.
We have a question from Trisha. Was the noise produced by drones a challenge or not? How close can we fly a drone when we are tracking any animal or bird?
Yeah, great question. That was one of the first questions we asked ourselves, in fact, for when we're like, is this possible? You got this buzzing, whirring, noisy thing. Can you actually listen from something like that? It really hasn't really been a huge challenge. In our initial system, it was more of a challenge, but with the way that we've built the system now, it's not a problem at all. So that's been great. There's many other challenges that aren't drone related, but the drone itself doesn't cause any problems. And in terms of how close you can fly the drone when tracking, well, you can fly right over the top of them, really, but that's not what we want, because if we're actually trying to triangulate the animal, where the animal is, you don't want to be too close, because if you're too close, the signal will be strong in all directions. And so the drone will go, well, I actually don't know where it is. because it's actually right underneath. So we actually want to be further away. So when you rotate the drone, it's actually strong in this direction and weak in this direction. And then you can do your algorithm and point the antenna, point the arrow on the map in that direction. To give you an idea of the different distances, so the biggest tag that we have tracked is actually a satellite tag used on feral pigs here in Australia. So it's like huge. I could put it over my neck and it would kind of be loose. Very big tag. But most of it is the satellite component. But that also has a VHF signal, and we can pick that one up from 9 kilometers away. So that's really quite, quite some distance if you're looking for one animal in a very big landscape. Right down to microbat tags, which weigh 0.2 of a gram. So like really tiny tags. And we've been able to pick up those tags up to 1 kilometer away. So that's the kind of range that you're looking at. There are some other tags that maybe they have an internal antenna rather than a whip antenna, and they tend to have a shorter range than so the type of tag, the type of antenna, the size of the tag, they all have a big bearing on what that distance is. But what we like to do, if people are interested in finding out that information, like anybody can just send us some tags and we'll do some testing and actually measure what that is, because that actually provides you with really a lot of information for your flight planning when using the drone. So okay, well, if I can pick these tags up from 2 kilometers away, you don't have to do grid patterns like you do with a visual survey. That would actually be wasting a lot of time in this regard, because we can pick up signals from a long way away. You want to be able to just fly in as big an area as possible and know that you're covering a 2 kilometer area in one direction at the moment, because it's a directional antenna. But we are also working on a dual antenna, so we can actually listen in 2 different directions at the same time and cover twice as much area. That really it enables you to cover really big areas quite quickly when you're searching for things.
Thank you. We have Amit.
Hello, ma'am. Actually, another question that was like pretty similar to the last question, but like what I meant is radio signals, like not radio signals, rather animals are specifically like aligned to be they can feel the presence of radio signals. A few animals, like for example, bats can feel the presence of ultrasonic signals. Few others are there that can take the radio signals. So, do you differentiate between the frequencies for different animals, or it is a common frequency that is used for all the animals?
So at the moment, where each animal has their unique frequency. So typically when people are trying to track their animals, most projects that kind of track maybe at the moment have only been able to really track maybe 20 or 30 animals maximum, because it's just too difficult to manually to track any more than that. And so that's the kind of numbers that people typically work with. And when they order the tags, when you order the tags, you can actually specify what frequencies you would like, and you typically get them nicely spaced so they're not too close to each other. And so it really is just limited by however many animals you want to track, and each one is unique. And so when you enter the tag information into the base station, you actually can put in a label, you can put the name, like some people actually have names for all their animals, or some people might refer to them by the frequency or whatever. You can put reference information in there, and all of the data is labeled with that information. So typically each individual has a unique frequency. But as I mentioned, we are interested in exploring also the potential for tracking, like decoding tags while we're flying as well, because that means that you can actually have many more animals that you can track at the same time. And that sort of a system is in use probably most extensively in the United States, where they have lots of towers. and the small migratory birds pass through. The towers, from what I've heard, they don't give you specific locations, but you know that the bird has gone past this tower, and so they get the really big scale movements. But it is dependent on there being towers, and so as soon as the animals move beyond the towers, there's no way of finding them. And so that's some of the challenges of people who have those systems set up have come to us and gone, look, it's great. We know where they are when they're inside the towers, but as soon as they go outside the towers, which is, 3/4 of their life, we have no idea where they're going and what they're doing. So this is where I'd really love to be able to help to find those animals beyond the towers or beyond the boundaries of what people are using those particular tags for. But the way our system tracks at the moment is that it looks for the peak of the signal at each of those frequencies, and that is what it is direction finding. So if you had lots of tags with the same frequency, it would just be incredibly confused. It would just go, oh my gosh, they're like everywhere. They're over there, they're over there, they're over there, and it wouldn't know where to point because it's all the one frequency. So the current setup does not work with coded tags, only with unique frequencies, but we're exploring whether that might be possible as well.
Thank you for that.
No worries.
Nikita, do you have one more question? Or is it a previous hand raise?
I just wanted to ask, for example, you tagged an animal and by somehow that tag got removed. As you said, there's a lot of probability, So is there any chance to retrack that specific animal, or how do you do that?
Sorry, that's if the animal is tagged. I didn't quite catch the question.
So, so my question was okay, an animal got tagged, right? So after a specific period of time, that tag didn't work or it fell down somehow, and so how do we retrack those animals?
Yeah, that's the trick, right? So you have to get back to the animal before it goes dead. So typically when you order a tag, they will give you a lifetime of the tag on how long they expect it to last. And depending on the environment and the type of animal that you're using, the battery life will battery life determines the size of the tag. So the bigger the animal, the bigger the tag, and the longer the life of the tag. One thing that I do find quite interesting, which is kind of just a side effect of us being able to listen for the pulses now, is that we can actually see tags dying, because they're supposed to be like 60 pulses per minute, for example, and then all of a sudden it'll be like 30, 40, 20, 15, 12. You can actually physically see it dropping. And so if you were using this system in a case where the tags are getting low on power, you actually would be able to target your efforts to recapture in the animal for those where the signal is dropping, and it gets more erratic as well, the signal. So you actually get a bit more warning than you typically would, but that's one of the key things that I think if people want to retag an animal, then you need to allow time to be able to find the animal before the tag expires, because once the tag expires, there's nothing to track anymore. But in the instance where an animal has been tagged but the tag comes off, because that can also happen, then you're literally tracking the tag on the ground. But what we do find is that if the tag is on an animal compared to being on the ground, the signal strength is reduced to about 1/3 of the total strength. So once a tag comes off an animal, it actually gets harder to find because the range is much shorter. So what we tend to do when we do our tag testing, where we're looking at the distance we can detect them, we try it sort of in the context of the animal, but we also put it on the ground. so that if they're having trouble finding an animal, they then can adjust the flights so that they can have a greater chance of picking up a tag that happens to be on the ground, which can be really helpful, especially in captive release programs where you are interested in that dead or alive. You don't necessarily need a location. They want to know dead or alive, but as soon as something is being recorded as dead, they want to get there as soon as possible so they can ascertain what the cause of death was for that animal. In the case of the swift parrots, I loved it because the birds would chew the tags off and they would fall on the ground, and they're a bit tricky to track when they're on the ground. But we got all of our tags back, and I still use them. So we use it for testing all the time. So it means that you can get your tags back. You can put it on a different animal, perhaps. You might not get it back on the same one, depending on, how you catch them in the first place and how likely it is that you'll catch the animal again.
Sure, thank you.
No, thanks.
Debbie, how do you figure out the regulations for all of this?
So all of our work so far has been within line of sight or extended line of sight. So sometimes here we actually can, as long as you can see the airspace around the drone and you have a pilot with certain ratings, they can fly a little bit further. So we haven't really had problems. When an animal occurs next to an airport or restricted airspace is probably the bigger challenge. So that's the first thing we check whenever somebody wants to do a project is that, well, let's just look at the airspace first and see how complicated it's going to get. You can still fly there if you get the permit, but it takes time, it takes money, and is often not very flexible. And so, it was actually quite handy when we were tracking for the orange-bellied parrots. Unfortunately, the release site for that bird is right next to a major airport. And so a very challenging airspace. You have to kind of keep aside from it most of the time. But when we went and did that, it was actually during the COVID outbreaks, and we had been pretty fortunate that we had been in lockdown, but then it eased and I was able to go on a field trip to go and help track these birds. And because of COVID, there was no flights at the airport. So the airport was shut. And so it was quite a unique opportunity because I could just go and fly around. It was open only during certain hours. So we had to get there very, very early in the morning and do as much tracking as we could close to the airport early in the morning, and then we would go further away once the airport opened. But so we have had to do a little bit of a juggle in that instance. But I think one of the challenges in some of the states in Australia is actually in the national parks. Some national parks here where I live is very easy. You can go and fly your drone. It's no problem except for a couple of specific areas where you can't. But in other states, you're not allowed to fly them at all in the national parks. You have to apply, and it's very, very long, like months and months and months or a year before you can get a permit, and it's prohibitive. But there are ways around these things sometimes as well. So actually we discovered that if you launch and land from outside of the reserve, it's okay to fly over the reserve and things like that. So it's a good idea to kind of try and look into the details sometimes if you're finding that it's proving a bit challenging. If you can talk to some local people who are in the park rangers, for example, and they go, well, actually, if you just go outside, then it's okay. So we have done that a fair bit, which has been really handy. But that's the main thing. And I guess for the drone, the size of the drone that we're flying, we have to have a formal pilot's license, and we also have to have an operator's certificate. So there's 2 levels of certification, which it seems daunting when you're thinking about, I've got to get the license and then I've got to get this other thing. But I actually really loved that process because the pilot's license was all about, how to fly the drone and, learning about airspace and things like that. But for the operator certificate, it was all about reading aviation maps, and I love maps. And so it was just kind of like, this is cool. I really just thought it was really fantastic. There's a whole new world of maps that I'd never really seen before. And once you get that operator certificate, you have so much freedom to fly wherever. If you go to an airport, you still have to apply, but all the other places, as long as you have landholder permission, you can just go fly wherever. It's very, very flexible. And so I was really scared about, how am I going to pass this exam? Because I had spoken to some pilots who were actually they were human piloted aircraft pilots, and then they became drone pilots, and they said, it's really, really hard. Almost failed. And I'm like, oh no, like if you're an expert, how am I ever going to do that? But I don't know, it was actually fun. I loved it. So I think sometimes you've just got to bite the bullet and just go for it and give it a shot and see if you can do it. But I think that for me was very empowering, because then I was able to just go practice a lot more, go fly a lot more, go to different places, had a lot more freedom to just go and do what I wanted. I don't know if do you have similar kinds of conditions?
We have similar in India as well. So we need an operator permit separately, and then we need a drone pilot permit separately.
Yeah.
And both of them are slightly expensive, not much, but makes sense to go by the regulations. But we also
yes.
have had a lot of objections coming in from the national parks where we want to fly, wherein they say that this is restricted area, you can't really fly here. So we are trying to figure out how do we really go about it, and how do we rather convince
look
them,
at those boundaries.
Right. So if we have comparative case studies from around the world that this is what was done in these forests and nothing happened, so probably they would be happy with that.
Yeah. Okay. Yeah, it is interesting, and even in different states in Australia, very different attitudes towards it. So in New South Wales, you have to apply, but it's not particularly onerous. But you've got to figure out who to ask, because it's a local thing. It's not a centralized thing. In Victoria, it's quite prohibitive. They really just don't seem to. They've just made it incredibly difficult. But in the ACT, the capital here where I am, it's really open. So I fly in the nature reserve all the time, and there's no problem. So it really does vary quite a lot, even within one country.
So also your personal relationship with these rangers would matter?
I often don't know them. Australia's pretty big, like India, I guess. And so the places where we're going to, like, for example, next week I'm going out tracking koalas again. And it's in an area that I have never been before. So I don't know the person, but you just contact the local park office and find out what the form is and provide the insurance details and blah, 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 do all the paperwork. And that's kind of all that's required, but really good to check in with them anyway. For example, the koala one, I was originally going to be doing that this week. But when we checked in with the national parks people to get the permission, we found out that actually they're doing some aerial control work for pests this week. And so they were going to have planes flying around very low all week this week. And so it really would have been very dangerous to have been there if we hadn't actually asked for permission, because we didn't know about those aerial operations. So it is quite important to make sure you talk to the people on the ground and see what's going on at that time.
Thank you so much, Debbie.
Okay.
So I don't think we have more questions from the participants. And I also know that it's too late at your end, and you need to rest. So thank you so
that's
much.
Okay. I did have one more little section. I don't know if we can wrap up now, but I do have one more shorter presentation if you're interested in a little bit more.
Yes, of course. Why not?
Yeah, cool.
Thank you.
Okay, I'll just pull it up. So this one is really, it's a bit about the journey we're on at the moment, where we've been approached by people to track livestock, and we were like, well, we don't actually care what type of animal we're tracking. If it has a radio tag, we can track it. So whether it's a cow or a sheep or an alpaca or a bird, it doesn't really matter to us. So we're exploring this a bit more at the moment to see whether we can also add value for people in the agricultural space. And so I keep mucking around with my screens. So we've decided to set up, I guess, a sister product of wildlife drones in the form of ag drones, and really just, I think there's a whole raft of different applications in the agricultural sector that also would enhance our capabilities in the wildlife space. So it's been really quite fascinating. The idea would be that we would still just tag the animals. Now, this tag in livestock can actually take quite a few different forms. So here we have an example where would actually be a rumen tag. So it's a tag that can actually be placed like just through the mouth. We can pop a VHF radio tag into the rumen of the cow, and it's actually a permanent form of identification, and that can be tracked even though it's inside the body cavity. There's some great advantages to that type of a system, and one, that it can't be lost, because one of the things that we have found from talking to farmers is the biggest pain point is here in Australia, they have to have ear tags for their identification and tracking, like, tracking of individual animals in terms of paperwork and throughout the life of the animal. But often those tags come out, and that's very, very difficult to keep track of which animal is which, and it takes a lot of time and effort to replace those tags. So some people have shown interest in using rumen tags, but the thing is that with a rumen tag, because it can't be lost, it also means that if your cattle are stolen, it could still be tracked, because that people don't know that there's a rumen tag inside that cow. And so if there is a problem with livestock theft, as there is in South Africa, well, in many places in the world, here in Australia as well, but I think in South Africa, the theft of livestock actually results in people's lives being threatened. People get shot trying to retrieve their cattle. So it becomes a life and death situation. And so people there are really quite interested in being able to track livestock remotely, because any other type of tag, even no matter how sophisticated, it might be a satellite tag, it might be a GPS tag, an Internet of Things tag, all of those things are on the ear or on a collar, and as soon as an animal is stolen, they're just ripped off. And so you therefore lose that. They even rebrand the animals, apparently. And so the rumen tag is the only way that they can really positively identify an animal as being the animal they think it is. So that for us is quite interesting. I don't believe that there's any other solutions that really can do that available in the market. And but we can track an ear tag or a collar if they wanted to use that as well. So it's really quite open. But the whole theory is exactly the same. You have a tag, you attach the thing to the drone, you fly the drone, you get the data, you can find where they are. And so it's really about taking, this technology that we've shown to work with wild animals that don't have fences, they don't have boundaries, and applying it to the agricultural sector. And this, I think my original thoughts were that this would be most valuable on properties where it's very, very big properties, where they don't have fences. And in Northern Australia, we have those types of properties. But in many other places in the world, it's a very different structure to the agriculture industry, where you might have lots of smaller farms, etc. So it depends on the farm, but it also depends on the circumstances of the farmer, because what we have found is that there's some young people coming through the farming system that are really interested in embracing technology and trying to do things more efficiently. But there's also the older, like the most old generation, that are actually getting so old it's very difficult for them to go around the farm all the time. And so they are also looking for some technology solutions, and not just tracking the livestock, but really, I think a lot of the time they just want to have a visual, they want to have some vision on, you know, what's happening with the water tanks, what's happening with the fences, you know, which roads are flooded, or, you know, what's going on the property, without having to go through 50 gates and going open and shut the gates, open and shut the gates, whatever. So, yeah, so this is something that we're exploring at the moment, and quite keen to hear from people who might have some ideas about the applications in this space. There's certainly predicted to be quite a major growth in the agricultural drone market, everything from spraying drones, visual drones, you know, looking at vegetation indices, etc. And for looking at productivity across the landscape and water, sometimes using thermal cameras as well. So there's a whole raft of different applications that are possible, but I think as well that farmers have really been dealt a lot of different possibilities that haven't quite met their needs or addressed their needs. So we really want to make sure that we're talking to the people on the ground and finding out what the problems are and what it is they really need, and whether this, you know, might provide a valuable solution for them. So from the people we've spoken to so far, these are the things that we've come up with. So a lot of the time there are lots of tracking solutions out there for livestock. So there's lots of Internet of Things systems where, you know, there's towers set up and that sort of thing. And that's actually really helpful at a really small scale, where, you know, they're in quite small paddocks and you can tell where they are in the paddocks and you can get lots of information remotely. So that can be really great. But as soon as you get to properties that are of a larger size, all of a sudden you're trying to manage infrastructure right across all these different places, and it really becomes prohibitive. And they're using towers, and if you have hilly, it's a bit like when you're radio tracking wildlife. As soon as there's a hill and there's vegetation and other things in that landscape, the towers become less and less effective at the covering the area, or covering all areas. So a lot of people have said one of the biggest things is being able to find their stock so they can muster them. So at the moment, some people are actually getting helicopters to go out and find them, which are incredibly expensive, and dangerous as well, because they do lots of low level flying, and accidents do happen quite often. The other one is the lost or stolen livestock. But interestingly, a lot of people say, actually, I want to track my staff, not because they want to sort of, you know, impose on the staff, but they often, you know, don't take their safety gear, or don't, you know, charge the radio that they need to communicate, and they might hurt themselves. And then the farmer will spend a lot of time just trying to find the staff rather than the livestock. So I found that quite interesting. It's come up again and again, but I'm thinking that, you know, you could actually tag the vehicle that the staff are using, and you could easily track that. So it's one possible solution. I've already talked about the rumen tags and that traceability of the animal, and just not needing that infrastructure. But I think one of the key things in this area is that the drones, you know, there's so many things so many different sensors that you can use. And with one drone platform, you know, you can have a thermal camera, an RGB camera, and a radio tracking system, and you can do so many things across the farm, and save a lot of time and effort in doing that. This is actually an example of what I talked about before, about the feral pig tags, and we can detect them from 9 kilometers away. So if you actually wanted to do some control of some pest species, you can actually tag some of the animals and track them, and they actually will lead you to the whole group of animals, so enabling you to capture them or to manage them in a way that you need to. And this is an example of some of that thermal imagery that I was talking about. In this instance, these animals are causing a lot of damage to both the agricultural landscape as well as the natural areas, and they're very wary. They're very smart animals, and they don't like being near people. But they can actually get quite close to them with the drone without them being disturbed if you can just stay high enough. And so they really do like pop out of the landscape because they're nice and they've got the reflective signature there. And this is some of the other applications. I think the water troughs is a really big one. In particular here, we have a lot of very dry country where the cattle are, and so water becomes really quite a life or death situation for livestock. And apparently, quite often, some of the livestock will fall into the trough. And if an animal is in the trough, then all the other animals won't drink. And so you can actually lose a whole herd or flock of animals by not being able to check your water troughs enough. And of course, there are cameras you can get for water troughs, etc. But again, it's more infrastructure, more connectivity you have to set up. Whereas a drone could actually just go around on a pre-programmed flight path and actually check all these things. So I think there's a lot of advantages there in a number of different ways. And then there's also, other applications. I'm quite interested to explore the evaluating the health of animals with thermal cameras and seeing if it's possible to detect cows that might have an infection and a raised temperature. Calving is part of the life cycle that is often where a lot of losses occur. And you can actually get birthing tags so that when the calves are born, the tag will actually start transmitting. So could actually use the radio tracking system to find the cows that have had their calves, and you can actually go and check on them visually with the drone as well. And some other things that I'm really interested in exploring moving forward is being able to upload data from different sensors. So this sort of, I guess, came about thinking about the agricultural sector, but also I think it's equally valid in natural environments and environmental monitoring programs. It might be camera traps, it might be acoustic monitors out in the forest where you're collecting lots of data and you have to go around and get a little SD card and then copy it and then put it back in. It would be so fantastic, I think, if we could actually use the drone like a data mule, if you like, and be able to upload that data in really big natural landscapes, which is not really possible unless you actually set up a whole massive network of towers. And I think that eventually I see that all of this stuff, whether it's a farm or whether it's environmental monitoring projects, I think there's great scope for automating a lot of it, but not so that people don't go out there, because I think it's really important to harness the knowledge of the people who are on the ground there, but actually to complement it. So get the drone to do all of the boring regular stuff, like get the core basic data, so then you can go and supplement that data with more information on the ground. And so we are actually, there's some very nice looking launching and landing platforms that are available now for off-the-shelf drones, and so we're hoping to explore that a bit more as well and see if we can actually go back to having a sort of a semi-autonomous system for farms, which will actually overcome the need for individual people to go and get their pilot's license, because you can actually have remotely piloted systems set up so that there's a control center that operates the drones, but the farmer gets to sort of choose which inspections he or she might want to do at any time. So I find that also those sorts of things are really quite exciting. There'll be lots of, over time, image recognition and machine learning and a lot of other things that I think will just sort of explode in this space in terms of the capability of what might be possible in the future. So I think that's it. So it'd be really, really wonderful to be able to keep in touch with people here who, and it's been really enjoyed the interaction and lots of questions, and really, really great questions that have been coming out. It's been very enjoyable for me. Thank you.
Thank you, Debbie. I think this was been one of the most interactive session of this course as of now.
Great.
and I think everyone has enjoyed it. I would last maybe ask just one more time if anyone has any more questions for Debbie before we close for today. I guess no. So they've
No,
already asked their
it's
questions. So thank you so
okay.
much.
That's cool.
And
My pleasure.
agriculture drone sounds really good, and I'm very happy that you introduced it. I remember last year when you had shared this, I think we had asked you this question as well. Would this work for livestock? And you said, yeah, it would work for any other animal. So I'm very happy that this finally came out as a product, and all the best for that. And
Thank
I
you.
guess maybe we can experiment some of it in our countries as well, hopefully. And
Mm,
hopefully we learn from this and we'll take it forward. So thank you
yeah,
once again for being on the course,
my
Debbie.
pleasure.
It has been an amazing session with you, learning so far, and we hope to have you more often.
Oh, thank you. I'll have to. Maybe I should shorten my story. I don't know if I don't want to say the same thing again and again, but
I
this was
know.
this
This
was a
is,
nice
the story is
opportunity.
amazing.
A nice
Indeed.
opportunity. Yeah, it has been a while since we last spoke, so there is a bit of new stuff in there for you. But
Yes, yes. And there has been new developments. So I'm very happy for that. Thank you
yeah,
so
thank
much.
you, thank you. It's been really wonderful. I look forward to continue being involved.
Sure. Thank you so much. Thank
Good
you
luck with
for
the
being
rest of
so
it.
generous with your explanations, your knowledge sharing, and your stories as well. Thank you.
My pleasure. Okay, thank you.
Bye
See
bye.
you.